This lesson is about simple integration and its application in physics. Hello, welcome to Physics is Easy with Mr. Jesse. Consider this velocity time graph. So at this particular segment A, if we are going to integrate the segment A, basically what we are doing is just to obtain the area under segment A. So once again, the meaning of integration is solving for the area under a curve. So if we have a velocity time graph or velocity as a function of time, if we integrate this, if we integrate that, we will be able to have displacement as a function of time because the area under a velocity time graph is displacement. So that is the area under the velocity time graph. By definition, integration is a process of finding the antiderivative of a certain function. It is in fact the reverse of differentiation. So for instance, we have the derivative of an unknown function with respect to x is equal to 5x to the fourth power. So the question is, what is the unknown function? So if you think of that function, or f of x, is actually equal to x raised to the 5 or to the power of 5. So once again, if we take the derivative of that particular function, x to the power of 5, that would indeed give us 5x to the fourth power. Now the process of finding this is actually what we call integration. Speaking of integration, there are actually two types. We have the indefinite integral and the definite integrals. The symbol for integration is this squiggly line right here. So this is the symbol of integration. Let me write that down. Symbol of integration. And if we are going to integrate a certain function, let me just write that down. Symbol of integration. And if we are going to integrate a certain function, it is always with respect to a variable. So, for example, if we have y is equal to x squared minus 4x, if we are going to integrate this function, it should actually look like this. So the integral of x squared minus 4x, and we will have dx. dx right here is what we call a differential. That is a differential. A differential basically tells us what is the variable that is involved in the integration process. So sometimes it could be dy, it could be dt if the variable is time, it could also be d theta if the variable is angle, or so on and so forth. Rules of integration. There are actually several rules in integration, but for this lesson, I'm only going to teach two important basic rules of integration. The first rule is the integral of a constant k with respect to x would be equal to whatever that constant is multiplied by the variable that is defined by our differential plus a capital letter C. So I'm gonna discuss later what this C means. So basically K here is a constant. So if we are going to integrate a constant, it would become this expression. Let's have an example. We have the integral of 7 dx. So that is equal to the constant, that is 7, multiplied by the variable that is defined by the differential, in this case that's x, plus c. Now this c right here could actually mean any constant. What does this mean? So for example, if our expression or if our function is f of x is equal to 7x plus 1, the derivative of this function f prime x is actually equal to 7. Or if it was 7x plus, say, 1/2, the derivative is still going to be 7. So as a matter of fact, the c here signifies that 7x can possibly have a second term, and that second term is a constant. The second basic rule of integration that you need to know is this. The integral of x raised to the power of n dx is equal to x raised to the power of n plus 1 divided by n plus 1 plus constant. So this is a general solution. So for example, if we are going to get the integral of 5x to the fourth power dx, this is just equal to, just copy the numerical coefficient of our original function, then we will have x raised to the power of 4 plus 1 divided by the exponent, the new exponent. So in this case, that's going to be 4 plus 1. Do not forget the c, or the constant. Then we will have 5 raised to the power of x times x raised to the power of 5 divided by 5, and that is equal to 5. Oops, we forgot to write the constant. Plus c, and that is equal to x raised to the power of 5c, because we will be able to cancel that 5 there. So this, in fact, here is the integral of 5x to the fourth power dx. This is what we call the general solution. So basically, when we are going to integrate something and it contains the c, that is a general solution, and or in other terms, we are actually doing indefinite integration, meaning to say again that we have an indefinite number of possibilities to complete our original function, because c could be any constant. Now let us look at this velocity time graph once again. If we focus our attention to these segments right here, which corresponds to time equals 15 seconds up to time equals 30 seconds, that segment has actually an equation, or can be defined by the function y is equal to negative 4x plus 20. Now, if we are interested to solve for the displacement of the object at this particular segment, what we need to do is to integrate this function. So let's do that then. So our function is negative 4x plus 20, so we would say the integral of negative 4x plus 120. Don't forget to put our differential. So in this case, we are integrating it with respect to the variable x. So this is equal to, we just have to integrate this based on the two rules that you have learned. So for x, we will have negative 4 multiplied by x raised to the power of, initially it has an exponent of 1, so we add 1 to it, divided by the new exponent, so that's going to be 1 plus 1, then plus the integral of 120, since that is actually a constant, it's just going to become 120, and do not forget to add the constant 120x rather, and don't forget to add the constant c. Now I do understand that if we are going to integrate negative 4x, it will have a certain constant c, and integrating again 120, it would also have a certain constant c. But if we add a constant c plus a constant c, it would still give us another constant. So we don't actually need to write c plus c. Okay, so let me just remove one of the c's there. Alright, so let's simplify this one now. We will have negative 4x raised to the second power divided by 2 plus 120x plus c. Alright, moving on. We will now have negative 2 x squared plus 120 plus c. So this is the indefinite integral for this particular function. This should be 120x. Now, to make more sense of this general solution, for instance, we are interested to know the displacement that the object will be able to cover from 15 seconds to 30 seconds, then we should be able to define the limits or the boundaries of our integral. So when we are now going to define the limits or the boundaries of our integral, we call that definite integral. So let me write that down. Definite integral. So how do we write definite integrals? So indefinite integrals would look like this. It's actually very similar to indefinite integrals. So for example, we are still going to use the same function. That's the integral of negative 4x plus 120 dx. And if we are dealing with definite integrals, now we will have the upper limit or the upper boundary and the lower boundary. So in this case, if we are integrating it between 15 seconds and 30 seconds, then our upper limit would be 30 seconds. Let me write 30 right there. And our lower limit would be 15 seconds, which and in this case time is on the x-axis. So we will have, according to our initial solution, it's gonna be negative 2x squared plus 120x. This time, since we have defined our limits, we are no longer going to put c, but instead we will write something like this. That's going to be the upper limit when x is equal to 30 and when x is equal to 15. So let me rewrite this again, this side here. So our upper limit is x is equal to 30, or the upper boundary, and the lower boundary is x is equal to 15. And when this happens, what we need to do is just to substitute the upper and the lower limits. So the function substituted with the upper limit minus the function substituted with the lower limit. So what do I mean by that? We will have negative 2 multiplied by 30 squared plus 120 multiplied by 30. That is our upper limit. And we are going to subtract this with our lower limit, or we're going to subtract this with a function that is being substituted by the lower limit. So we will have minus negative 2x, and in this case our x is going to be 15. Once again, this is the lower limit, plus 120 multiplied by the lower limit, which is 15. And then we just have to calculate this. So we have negative 2 multiplied by the square root of 30 is 900, plus 120 minus 30 times 30 is equal to 3,600, subtracted by negative 2 times the square of 15. So the square of 15 is equal to 225, plus 120 times 15, that is equal to 1,800. So simplifying this further, we will have negative 2 times 900 is going to be negative 1,800 plus 3,600 minus the quantity of negative 2 times 225, that is equal to negative 450 plus 1,800. So the first term, we will have negative 1,800 plus 3,600, that is equal to 1,800, minus we have negative 450 plus 1,800 is equal to 1,350. Simplifying that further, 1,800 minus 1,350, that would give us 450. And since we are actually getting the integral, that means to say that we're getting the area under a curve, and the area under a velocity versus time graph is displacement. So the unit for this is 450 meters. So the unit would be meters. So now let us verify if indeed the area is equal to 450 meters by just solving the area that we have based on how we previously learned it. So we actually have a triangle right here, and in solving for the area, it's just gonna be equal to the area at that point from 15 seconds to 30 seconds would just be equal to 1/2 base times height. And in this case, our base is equal to, that's from 15 seconds to 30 seconds, so that's gonna be 30 minus 15 multiplied by our height, which is 60. Alright, so we will have 1/2 minus 30 minus 15 is 15 multiplied by 60 is, and that is in fact equal to 450 meters. So indeed we were able to confirm that the integral of a function is just equal to the area under the graph of that function. So in summary, if we are given position as a function of time equation, and if we are interested to obtain the velocity as a function of time equation, we just have to obtain the derivative. Furthermore, getting the derivative of velocity as a function of time would actually give us acceleration as a function of time. So this means then that if we start with acceleration as a function of time, we will be able to get velocity as a function of time by getting the integral of that particular function. And if we have velocity as a function of time, we could actually obtain the displacement as a function of time by again getting the integral of that particular velocity as a function of time equation. Having said that, it is also very important to note that there are two types of integrals. So we have the indefinite integral and the definite integral. When we say indefinite integral, our answer contains the constant c. On the other hand, for the definite integrals, we will have a certain upper limit and a lower limit to our to the integration process. And in that case, we will be able to get a fixed answer without a constant c. Now let us try to solve this problem by applying what we have learned on basic integration. The equation v of t is equal to 3t squared minus 4t plus 2, where v is in meters per second and t is in seconds, gives the velocity of a vehicle moving along a straight track. The vehicle's initial position is 3 meters. What is the vehicle's position at t is equal to 4 seconds? Okay, so we are in fact given the velocity as a function of time equation, and we are interested to know the position of the object at time is equal to 4. So to do that, we have to obtain the position as a function of time from the velocity time or from the velocity time equation. So we have to undergo through the process of integration. Okay, so to write that, we will have the integral of our velocity function. So that's going to be 3t squared minus 4t plus 2. And again, do not forget to write our differential, the differential which defines the variable to which our equation or function is being integrated. And that is equal to, we just have to apply the basic rules of integration to each term. So we have 3t squared, so that's gonna be 2 plus 1 divided by 2 plus 1 minus 4t 1 plus 1, because t is understood to have an exponent of 1, divided by the new exponent, so that's going to be 1 plus 1, plus the integral of a constant is just equal to 2 multiplied by the variable, or the variable that is being defined by the differential, and do not forget our constant. So now we're putting our constant because we have not really identified the limits of the integration. Simplifying this, we will have 3t cubed over 3 minus 4, or minus 4t squared over 2 plus 2t plus c. Simplifying this further, we will have t cubed minus we will have 2t squared plus 2t plus c. So this one right here is our position as a function of time equation. Now the problem states that the vehicle's initial position is 3, meaning to say that when time is equal to 0, the position of the vehicle is equal to 3. So we are going to use that in our position time equation. So we have when x is equal to, when time is equal to 0, our position is equal to 3. Meaning to say, if we are going to substitute 0 to the t in our position time function, that would be equal to 3. So let's do that. Let's write that down. So we have x of 0 is equal to 0 raised to the power of 3 minus 2 the 0 squared plus 2 multiplied by 0 plus c. So basically we will have, and since that's equal to 3, so we will have when x, at time 0, our position is equal to 3, so that gives us c is equal to 3. Again, we just substituted x of 0 with 3. That's why we have this expression right here. So now that we have defined what our c is, we could rewrite our position as a function of time equation. So we will have x of t is equal to t cubed minus 2t squared plus 2t plus 3. And if we go back to the problem, it's asking us what is the vehicle's position? What is the vehicle's position at time is equal to 4? So let us solve for that. Wait. Okay, there we have it. So meaning to say we need to solve for x of 4. So x of 4 is equal to 4 cubed minus 2 4 squared plus 2 times 4 plus 3. Simplifying this, our x of 4 would be equal to 64 minus 2 times 16 plus 8 plus 3. Moving on, we will have x of 4, or the position when time is equal to 4, is going to be 64 minus 32 plus 8 plus 3, and that would give us x of 4 is equal to 43. And do not forget the unit, that's going to be meters since we are solving for position. So this is the position of the object when time is equal to 4. And that concludes this lesson. Always remember, physics is easy with Mr. Jesse.